Hi, my name is Jim Orrock, and I'm with the business development team with Evolve Additive Solutions. I have over 30 years experience in developing products for applications in healthcare, automotive, aerospace, and manufacturing. And today I want to talk about a technology from Evolve Additive that can produce injection molded quality plastic parts using 3D printing. And the benefits of that capability that developers can have throughout the full product development cycle, not just early in the prototyping phases. Often product developers are following a timeline of defining product requirements, working with your product marketing teams, for example, internally, conceptualizing product architectures, defining the subsystems and components that you'll need, and then procuring those parts and integrating them into systems for various form-fitted function testing and other kinds of test and validation work to help understand the design effectiveness that you've chosen. And getting those parts, today often there are options. You can pay for soft tooling to get parts, plastic parts. You can get them machined out of stock shapes. You can use 3D printing methods, which today have limitations, and you'll make some concessions on part density, part porosity, feature detail, or other factors that may be important to understand early in design validation. There are pros and cons of all those methods, but as I said, Evolve offers a method that produces production quality parts early. And when I say production quality, I mean parts that are fully dense, that comply with stringent dimensional tolerance requirements, that have flat surfaces, that have fully replicated feature details such as ribbing, holes, or even maybe hard to see in this video, but threads, for example, in this Turnal device here. And by the way, these threads as printed will fully hold 100 psi or greater air or water pressures, for example. And so having these production quality parts early in the product development cycle helps you understand design intent and effectiveness much faster. Because it's a 3D printing method, you can iterate much faster than waiting for soft tooling and tooling modifications. Often those soft tool parts have feature limitations, or even if they don't, the early first articles from them may have to be modified due to warping or other factors. So incredible benefits during that early phase of defining product requirements, getting parts, integrating them, and understanding system capability. And when you move on from that early phase of design testing and conceptualization, you're moving into more rigorous phases, and often this is where organizations are paying for hard tooling. They want to continue design validation and testing with tooled articles. And again, with Evolve's technology, you can continue to use 3D printing techniques because you're working with parts that are going to be identical to those injection molded parts that you may get when you scale to serial production. So now you've saved the time and deferred the cost associated with paying for hard tooling. In one organization I worked with, we planned on systematically on every project, for example, to have 4 iterations of tooling modifications because the first articles often showed some issues or defects or warping problems that we needed to fix. So saving the time associated with that tooling iteration can be tremendous. And if you're serving a regulated industry like aerospace or healthcare, and you are going to regulatory testing or some kind of certification testing, you have to go into that test with parts that are equivalent to those that you're going to have in production. And again, the Evolve technology can offer that solution, again, with no investment, even up to this late phase of development in certification and regulatory testing. But the benefits extend way beyond just having parts early and taking you through validation testing. Often product development teams are working hand in hand throughout the life cycle of product development with operations teams, including the manufacturing people and the supply chain group. And early on, supply chain must find qualified suppliers of these plastic parts. even if you're buying them as commodities or 3D printed parts early, the risk of that supplier being in business 2 years from now when you've completed product development can be high. There's business continuity issues, or the products you select may be rationalized out of a product line for a supplier that you've chosen. So these supply chain teams are dealing with a lot of risk, and furthermore, when you get towards the end of a product development cycle, a system product, for example, and you also need to make accessories or forecast spare part needs and so on for that product. Those designs have been deferred and you're waiting for final product validation, so that you can effectively define to interfaces that may be finally finalized. So again, if you've been using the Evolve technology throughout the development phase, early for prototyping, later into more functional system verification and design verification testing, you have a qualified supplier and process already in place to make spare parts. And you may even use the technology to make custom spares, for example, if that can be a differentiator in the market you're serving. So the benefits of having production quality parts early and through the middle and later phases of product development are incredible in terms of time and cost savings and risk reduction. So I would encourage you to take a closer look. If you make plastic parts and are integrating them into system products for your applications, I would encourage you to take a look at the Evolve technology. Thank you.